Hello everyone, and welcome to my first video ever for algebra called Solving Equations with a Single Variable, Single Step Algebra. If you want two-step algebra, you're going to have to wait till my next video to get this one jump started. But let's proceed on to the actual math. So, hidden assumptions teachers make about you. They assume you know how to do basic arithmetic, like 2 plus 2 equals, there you are, and 4 plus 4 equals, and 8 plus 8 equals, and of course 9 plus 9 equals, pause for effect. There we go. They're also assuming that you know how to do basic multiplication and basic division. But if I was to take out something like the 2 that just vanished, or the 4 that is slowly wisping itself away, or the 8, excuse me, coming off a cold here, or if I take away the 9, then I should be able to say, well, what plus 2 equals 4? Or what plus 4 equals 8? Or what plus 8 equals 16? Or what plus 9 equals 18? Now, for most of you that have done basic algebra, or not even basic algebra, we're talking remedial math, we're talking like way back in the 3rd grade, then you should know that 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, and 9 plus 9 is 18. So you've already made most of these assumptions right away. But what if those assumptions are no longer valid in algebra? So what if I had to do math today? Well, let's take those things that we said what for, and we'll say what plus 2 equals 4. And, of course, what plus 4 equals 8. Now again, for most of you who have done your math way back when and you got really good at it, you should already know half these answers. But teachers may not accept that as actual work. So we're going to see what they want you to do to get to that missing boxed value. So in this case, we turn this into an equation 4 minus 2. And we, instead of saying what plus 4 equals 8, we said what equals 8 minus 4. And then we say, well, what equals 18 minus 9? Now, if I replaced all these what's with x's, well, guess what? You just turned this into an algebra problem. The idea here is that if I see addition, then I should think the opposite, which is subtraction. So take away 2, and I should have 4 minus 2. Take away 4, and I should have 8 minus 4. Take away 18, and I should have 18 minus, or I'm sorry, if I take away 9, then I should have 18 minus 9. And then you can just fill in the blanks accordingly. But does this also work with subtraction? Because we still want to think in terms of opposites. Let's generate a few equations here. So what minus 2 equals 2? And again, for those of you who have already got the answers, there are some cases where you do need to show some extra work, or you need to show what you're doing in return. So what minus 3 equals 6, and what minus 9 equals 9? Well, let's think opposites. What is the opposite of subtraction? Well, wouldn't that be addition? So what should equal 2 plus 2? And what should equal 6 plus 3? It's okay if you didn't get it the first time. And what should equal, there you go, 9 plus 9. And again, I replace all those what's with x's. Guess what? You turn this into basic algebra. So when we saw subtraction, we should think the opposite, which is addition. So instead of what minus 2, it should be 2 plus 2. Instead of what minus 3 equals 6, it should be 6 plus 3. And instead of saying what minus 9 equals 9, you should think 9 plus 9. You generate your answers, and you should be able to plug them in accordingly. But again, what about in terms of multiplication? This is the one that students have a lot of difficulty with. So we're going to write this out as you would in 3rd grade, where you have 2 times 2 equals 4, and 3 times 3 is 9. And again, these are all hidden assumptions here. We think that you know how to do this already. And what times 4 equals 16? So if I'm still thinking in terms of opposites, and I wanted to rewrite these as algebra problems for a student, well, I would say what times 2 equals 4? You'd be surprised how many people get this wrong the first time. And what times 3 equals 9? And what times 4 equals 16? Well, let's see here. Thinking in terms of opposites. Well, we know we want the what, and the opposite of multiplication is division. So we say what equals 4 divided by 2. Oh, and notice the placement of each of these numbers. So what equals 9 divided by? And what equals? There you go. Now, if you replace all those boxes with an X, congratulations, you got yourself some basic algebra problems, really basic problems. So what about division? Well, in the long run, you usually see like 4 divided by 2 is equal to, thank you, and 9 divided by 3, which is, and finally, 16 divided by 4 is, there you go. So if I replace just one of these numbers, let's say what divided by, come on, let me finish up this little box here. What equals 2 times 2? You should get 4. And what equals 3 times 3? So I'm going a little faster here this time around just because you're already thinking in terms of opposites. And if I took out the 4, the 9, and the 16, you should be able to bring me back those numbers. So for instance, what divided by 2 equals 2 is the same as 2 times 2. If I say what divided by 3 equals 3, then you should be thinking 3 times 3. If I say what divided by 4 equals 4, then you should be thinking in terms of 4 times 4. But what if you're dealing with fractions, everybody's bane? Well, fractions are no different than division problems. So some of the hidden assumptions we're making is you know that 2 divided by 2 is 1 and 3 divided by 3 is 1, using whatever method you find from before. So 4 divided by 2 is 2, and 9 divided by 3 is, there you go. Now notice I've been saying division the whole time. So what if we rewrote these problems similar to what we did before? So 4 divided by what is 2? 9 divided by what is 3? So we'd have to rewrite these over, thinking in terms of opposites, because when you're working with fractions, it's the same as division. So we want 4 equals 2 times what? And 9 equals 3 times what? And to solve these, you would have to use the multiplication that we did earlier. So 4 divided by 2 is really 2. And 9 divided by 3 is really 3. If this is too confusing, I'll have another video specifically on how to solve fractional problems in just a little bit. Now, most of the time, you'll see your problem set up in the other fashion, like what we did in the original division. So what divided by 3 is 3, and what divided by 4 equals 5. So again, if we were to set these up like normal division problems, or if you just want to memorize the patterns that we're having here, opposite of division, multiplication. And opposite of division is multiplication. So again, thank you for watching this video, and I know the fractions part was a little more advanced, and I'm going to have another video focusing strictly on fractions. But in the beginning parts, I hope that you understood the basics behind the division and the multiplication, And more importantly, you should be able to solve your basic single-step algebra problems.